Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Honors Geometry class. Today we're going to talk about something that we already learned about a while ago. I don't know if you guys remember, but when we were talking about proving angles congruent, we talked about side angle side, side side side, angle side angle, and we also learned angle angle side. It was not in the book, but for that section, but I went ahead and taught it to you. Well, today we're also going to revisit angle angle side, and we're also going to talk about a really cool theorem called the no choice theorem. And that's pretty much what we're going to learn about today. And the no choice theorem is pretty awesome. I like it. It basically states if two angles of one triangle are congruent to two angles of a second triangle, then the third angles are congruent. There's no choice. Let me explain what that means exactly. So I have this triangle here, ABC, and I have this other triangle here, DEF. And if A is, 30, and D is 30, and B is 50, and E is 50. Well, according to the theorem we learned yesterday, the triangle sum theorem, every single triangle on this universe has a total angle sum measure of 180. So if A plus B is 80, angle C has to be 100. Well, if angle D and E are 50, angle F have to be 100. So if two angles, in this case A and B and D and E, are congruent to each other, okay, and actually I should put a double one there, then that means angles C and F have to be congruent. No choice theorem. And you can actually literally put that on the proof. You can say for the reason, no choice theorem. So if two angles of one triangle are congruent to two angles of another triangle, then the third angles have to be congruent. There is just no choice. Okay? And then angle side, I know you know it, but I just want to reiterate it. If two consecutive angles and the following side of one triangle are congruent to the corresponding parts of another triangle, then the two triangles are congruent. Angle, angle, side. Now remember, it has to be consecutive, guys. So if I have it like this, angle, angle, side. Angle, angle, side. Has to either go clockwise or counterclockwise. Okay? Has to. Angle, angle, side. What if I went and used this side instead? Cool. Angle, angle, side. Angle, angle, side. That works. Okay? Now again, that's something that we already know, but we're going to revisit it here, so I figured it would behoove you to just see the proof again, or to see the theorem again. So we got no choice theorem, and we have angle, angle, side. Any questions on this so far, my brothers? Okay. We're good then? All right. Let's do this. I don't think I have anything down here. No. Let's do it. Okay, so right to examples. Easy peasy. Example number 1. They give you that angle A is congruent to angle D. They want to prove that angle E is congruent to angle C. Now, you guys should be able to just destroy this proof. You should be telling me today how to prove this. Talk to me. What do we do first? Good man. First, the given is that angle A is congruent to D. Remember, just because we're getting wiser does not mean we stop labeling. No, there's no reflexive here. No. Okay, 3 times the charm. Very good. What are the vertical angles here that are congruent, sir?
Angle ABE and angle DBC.
Yes, angle ABE and angle DBC. So angle ABE is congruent to angle DBC because of vertical angles are congruent. Reflexive, guys, remember, would be this. Let's say I had uh, like another triangle here like this. Okay. Then I wanted to use this whole angle here for all three. Then that would be reflexive. Okay. And you cannot use alternate interior angles here because there's nothing that's parallel. But vertical angles work very well. Yes, sir. And then
And then you prove angle AEB congruent to angle DCB
very
because
good. Angle E is congruent to angle C because of
there's choice theorem.
no choice theorem. Absolutely. Absolutely. Very well. Very well done. Pretty simple, right? Yes, sir, my brother. We've been, well, no. Well, okay, yes. Well, yeah, yes and no. You couldn't, we've never used the no choice theorem before. Before, if I wanted to prove that angle E was congruent to angle C, I would have had to have been given somehow, or that AB was congruent to BD, then I would have gone angle side angle, then I would have gone CBCTC, right? Or I could have been told that AB was congruent to BD, and then that EB was congruent to BC, and then I could have used subtraction property, and then again angle side angle, and then CBCTC. Yes, sir. You cannot prove that the triangles are congruent with the no choice theorem. No. You can only prove that that third angle is congruent. Very good question, sir. Thank you, sir. Good question, my brother. Thank you. Any other questions on that? All right, now let's get to the fun proof. This is the tasty one. Okay. They give you that N is congruent to R. Angle NTR is congruent to angle P. TS is perpendicular to PR. TO is perpendicular to NP. And TO is congruent to TS. All right. This is a bit of a monster. All right. So first off, like always, let's go ahead and start with my first given. Angle N is congruent to angle R. So angle N is congruent to angle R. Easy enough, right? Okay. Now what do you think would happen? Don't overthink it. Next given. Yeah, because I can't do anything with that information, right? So angle NTR is congruent to angle P. So let's go ahead and say NTR. That's this whole angle here. Okay, is congruent to angle P, which is right here. Okay. Now from here we can tell something. What can we tell from here? I am so proud of you. Well done, son. NPRT, which is the whole entire figure here, I'll outline it in red. This whole entire quadrilateral is a parallelogram. Now, I wish I could just let you say definition of parallelogram, but why is the definition of parallelogram? What property of the parallelogram proves that this is a parallelogram? Thank you, my brother. If both pairs of opposite angles of a quadrilateral are congruent, then it is a parallelogram. Now, I know some of you are going to say, can't we just use definition? No. There's a lot of definitions for parallelograms. So you have to know which one you're using. I am sorry, guys. Okay? So opposite angles, if opposite angles of a quadrilateral are congruent, then it is a parallelogram. After that, we don't have anything else to talk about, so let's go to the next given. TO is perpendicular to NP. So TO, even though it doesn't look like it, remember, you can't assume from figures. We can prove from figures. TO is perpendicular to NP. So that means that I'm going to have some right angles here, right? Does that make sense? Because it's perpendicular? Yes, sir? We're getting there, yeah. Thank you, my brother. TON is a right angle. I already know that because I labeled it right when I found out that TO was perpendicular to MP. And that's because of the definition of perpendicular lines. Now, they also say that TS is perpendicular to PR. So over here, we have another set of right angles. Now remember what we're trying to prove. We're trying to prove that MPRT is also a rhombus. Okay, we know it's a parallelogram, but we're trying to prove that it's a rhombus. So keep that in mind. So from here, if TS is perpendicular to PR, I can also say that TSR is a right angle. So right now, we're working with this guy right here. Why are we working with this guy right here? Because I want to prove that those two triangles are congruent, which I just outlined in blue. So I can have CPCTC to eventually prove that those two sides are congruent. And then we can prove a rhombus from there. Now, okay, I'm sorry. I should have put given here. And then this definition of perpendicular lines. I'm going to chill for a second. Just making sense. Yes, sir. No, I already got TSR as a right angle. That's where we are right now. I haven't done it yet. Thank you, my brother. Yes, sir.
Just out of curiosity, why did you only put TON and TSR as right angles and TO?
Okay. The question is, why did you only put TON and TSR as right angles? Okay. Does this right angle right here help me with anything? No. That's why. Is it a right angle? Yes. Could you have stated that it's a right angle? Sure. But is it going to help me with anything? No. Remember, I'm trying to prove again that this guy, now I'm highlighting it in green, I want to prove that this is a rhombus. I know it's already a parallelogram, but if you remember, one of the definitions of a rhombus is if a parallelogram has consecutive sides that are congruent, then it is a rhombus. So I'm trying to prove that TR and TN are congruent, so then I can prove that TP or NPRT is a rhombus. So now with number 8, I can say that TON and TSR, those angles, are congruent. Right angles are congruent. Or you could say right angle congruency theorem. You with me here? Yes, sir? No, not yet. Now you use the given that TO is congruent to TS. TO is congruent to TS. And now that you know that TO is congruent to TS because that's given, now I can use angle, angle, side and prove that triangle TON is congruent to triangle TSR because of angle, angle, side. Once I prove that TON is congruent to triangle TSR because of angle, angle, side, now I can say TN is congruent to TR because of CPCTC. Now I can say that NPRT is a rhombus. Why? If two consecutive sides of a parallelogram are congruent, it is a rhombus. Okay? I know you're writing that down. Go ahead and keep it up. I'm gonna leave it up here for you, but I'm gonna close out this video and start up for the next lesson. Hope you learned a lot. I will answer questions, but I'm just gonna start recording it. Thank you. God bless you, and I hope you learned a lot.